Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a short tutorial on how to write your own custom loss function in PyTorch. Let's get started. As I said, this video is going to be a short tutorial on how to write your own custom loss function in PyTorch. Loss functions are a critical component of training neural networks. They quantify the difference between the predicted output of the network and the actual target values in the training data. The primary goal during training is to minimize this loss, which is achieved through techniques like gradient descent. But why are loss functions so important? The first one is optimization. Loss functions serve as the objective to be minimized during the training process. They guide the model towards making more accurate predictions. The second one is evaluation. Loss functions help in evaluating the performance of the model. A lower loss indicates that the model is performing better. And the third one is regularization. Loss functions can be designed to incorporate regularization terms which help in preventing overfitting by penalizing large model weights. There are different types of loss functions: regression loss functions and classification loss functions. Regression loss functions are like mean squared error or mean absolute error or Haber loss. Classification loss functions are like binary cross entropy, categorical cross entropy, sparse categorical cross entropy, hinge loss, which is used in SVMs, and log loss. But how about custom loss functions? Where can we use them? The following show the places where a custom loss function can be helpful. Specific problem requirements. Sometimes the problem you are working on may have requirements that cannot be met by standard loss functions. Imbalance in data. When you have highly imbalanced datasets, standard loss functions might not be effective. Non-standard output distributions. If the output of your neural network doesn't adhere to a standard distribution, a custom loss function might be necessary. Incorporating domain knowledge. Custom loss functions allow you to incorporate domain-specific knowledge, which can significantly improve model performance. Error sensitivity. In some cases, you might want to penalize certain types of errors more or less than others. Custom loss functions allow you to define these penalties explicitly. Let's go to Python and see how we can design our own custom loss function in PyTorch. So as you can see, here is the code. First, we import the necessary libraries, and this code applies autoencoder to noisy MNIST images in order to denoise them. This is where we are loading the MNIST images, and here is where we are loading the training and the testing data, and this is where we're defining the autoencoder. This is the encoder side, and this is the decoder side. There are 6 layers in the encoder and 8 layers in the decoder part, so overall 14 layers. And here is where the forward direction of the input is specified. The input goes first into the encoder and then comes out of the decoder, as you can see here. And as you can see, this is our custom loss function, which is binary cross entropy. Then here is where we're going to be initializing the model. And then we're going to make sure we're using our custom loss function. And this is where we're setting up the optimizer. We're going to be turning the model for 10 epochs. We're going to add some Gaussian noise to the data, as you can see here. And then we're going to be clipping the values between 0 and 1. We're going to use the optimizer. So here is where the noisy data is going to be going into the model and the reconstruction is going to come out. And then here is where we're going to be applying the custom loss function. And then here is where the model is going to be optimized. And this is going to be going on for 10 epochs. We're going to be saving up the model. And then we're going to evaluate the model on the testing data, as you can see here. And then at the end, we're going to be visualizing the results. So you have to make sure you have set up PyTorch in your environment. So I had to come back and change the environment to PyTorch, where I have set up the environment for PyTorch. Let me open up the Spider. Okay, now we are ready to run the script. Let's run it and see what happens. So as you can see, the model is going through each epoch and the loss is also being shown here. So the run is complete. As you can see, these are the 10 epochs that we talked about. And this is the result of the run. These are the noisy images and these are the denoised ones. As you can see, the network has done a pretty good job denoising these noisy images. And that's about it. Thank you so much for watching this video. I hope you liked it and also found it helpful. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.